Okay, on the second part of this lesson, we are going to introduce three kinds of energy generators. The first one is the gas boiler. We will differentiate between condenser gas boilers and non-condenser gas boilers. The second one would be the pellet boilers. And finally, I will show you solar collectors to heat up water. So the first one is the boiler, the gas boiler. The natural gas, I think it's mainstream in not only in the United States, but for heating systems. Let's say that 70 or 80% of the boilers that we have in our planet, they run on gas. Why? Well, we have plenty of gas so far. It's not a renewable energy, so we will run out of gas eventually. But so far we have plenty of gas in the world. And when it comes to greenhouse gases emissions, it's one of the best fuels we can use. It's better than coal, for sure. It's better than any kind of oil, and it's much better even than wood. Okay, so gas is a good option. Maybe it's not the best option because it's not a renewable energy, but it's a good option. And we can differentiate between two kinds of gas boilers. We have the non-condensing boilers, and we have the condensing boilers. Condensing boilers are much better than non-condensing boilers. Apparently, they are the same. So we look at them and we don't see any difference. So this can be a typical gas boiler. And that's it. We have this chimney, so we have to apply another duct here to get rid of all these gases. And this is the gas intake. And here we have the burner, and there are inlet and outlet, water inlet and water outlet. So it's like this. It's like a red box, and that's it. But the difference between a non-condensing boiler and a condensing boiler is this. So in a non-condensing boiler, it's an old-fashioned one. If you are living in a 20th century house, most likely you have a gas boiler like this. So we have a burner here. This is the water pipes. So the intake is cold water. We have a fire here. So we heat up water. And then this is the hot water. And we distribute that hot water. This can be radiators or this can be radiant floors. The water cools down, and then we return the cold water to the boiler again. We heat up the boiler. So this is the cycle. If we burn something, we're burning gas, and we are producing these gases that we have to get rid of. So we need a chimney here. Okay, so this is the typical boiler. The condenser or the condensing or condenser boiler, it's something like that. So apparently it's the same device, so we don't see any difference because we have this is for the smoke or the gas. This is the gas intake. There will be a water inlet and a water outlet somewhere. But the difference is inside that box. We have like two spaces. We have the space in which we burn the gas and we heat up water. But the gas here, instead of getting rid of the gas immediately, we have another chamber in this boiler, and in this chamber the waste gas, which has a lot of energy because it's hot, because we have been burning gas here, so this waste gas, instead of getting rid of it, we move the gas through this chamber. We have another coil, another water coil here. So what can we get with this thing? So remember that we have released heat here, so we have cold water. So this cold water, instead of heating up the cold water by burning gas, we introduce this cold water in this second chamber, and the waste gas, which is very hot, heats up this water before getting rid of it. Okay, so this is the chimney. So instead of having the chimney right here, we have the chimney in this second chamber. So we make the most of the energy that we have in this waste gas. Again, do we need to know how this works? No, this is not for architects. We're not designing boilers. But we need to, if we specify a boiler in our house or in our building, we have to make sure that it's a condenser boiler, because the efficiency it's much better than non-condenser boilers. Okay, so I want you to understand how it works, but you don't have to design these kind of things. And I'm sure that in 10 or 20 years, there would be another system that would be more efficient than this one. Okay, but so far, this is a good way to design a heating system and save energy. So if we use condenser boilers, probably we will be closer to the passive house standards than if we don't use condenser boilers. Okay, the second option. So the first option is a gas boiler, and if I had to decide, it should be a condenser boiler. The second option, it's a pellets boiler. So I'm sure you're familiar with these pellets. In every gas station you can buy these kind of things, and there are a lot of people with these kind of boilers at home. Well, pellets are, well, it's wood, so it's not different. But it's not raw wood, so it's not the wood that we take from the forest, tree branches or whatever. No, we grind that wood, and then we create those small cylinders, and the burning capacity of those pellets, it's much better than the burning capacity that the wood that comes from the trees. Okay, so it's the same material, but well, we have to modify the wood, or we have to manufacture, or we have to modify the performance of that wood, and then we have these kind of boilers. But it's the same. We burn something. We burn the fuel. In the fuel, in this case, it's wood. It's not gas. Why do we use wood? Wood is very bad in terms of CO2 emissions. Okay, so let's say that the waste gas that we are getting rid of, it's worse than the waste gas that we have when we burn natural gas. But wood, it's a renewable source. Okay, so that's why these kind of pellets are considered as renewable energy. But again, we have to look at this, and that's why we have the concept of primary energy. So is it better burning gas, or is it better burning pellets? Well, we have to look at it, and this is not a straightforward answer to this question. So we will answer this question at the end of this semester. But so far, we can't, or I can't give you the answer to that question. Anyway, it's a good way to design a heating system. Wood, it's a renewable energy, and those boilers are economic, so it's not an expensive system, so it's good. And then my favorite is the solar. Okay, so we can have solar thermal panels to heat up water, because all these boilers heat up water. So this is the basic concept of heating systems. We can work with air, with heat pumps, but with these kind of boilers, we heat up water. So the most efficient, or the most efficient way to heat up water is using the sun. So if we have sunny winters, we can use solar thermal panels. That would be great. So why don't you see old roofs of New Hampshire with solar thermal panels? Well, because there are drawbacks in the system, and the drawbacks is that we have water, we are working with water, but those solar collectors, they are exposed, and we know that it's too cold. So sometimes the outdoor air temperature is below the freezing point of the water. So if water freezes here within the solar thermal panel, it collapses. So in mild climates in which we don't have temperatures below the freezing point, this is the best system. In very cold countries, it's a good system, but we have to be careful about that. I don't mean we can't use this, but we have to be careful, and maintenance, it's complicated in these kind of systems. Anyway, it's the most efficient because here we don't need any fuel. We don't emit any greenhouse gas. We don't burn anything, so it's perfect. The problem is that it's a freezing point. If we are below the freezing point of water, we can have issues here. So there are different systems. We will devote a class only to explain these kind of systems. And there is something that we need in this kind. Well, usually in all these heating systems, we need a buffer tank. So we need a tank to store water and to control the temperature of the water. In heating systems, this is in solar panel systems. We need a buffer tank because we don't have sun throughout 24 hours a day. We have sun only 6 hours a day in winter, if we are lucky. So we have to make the most of the sun energy during the day, and then we need to store that water to use it at the evening or at night. So the system gets more and more complicated, but we have, again, the same. We have expansion tanks, we have water pumps, so all these systems are the same. And then we can use this for hot water, or we can use this for radiant floors. Sometimes we combine things, so don't think that, okay, we have to use either a pellet boiler or a gas boiler or solar collectors. You can use everything at the same time. And in good buildings, we have different energy producers, because especially with the solar energy, if we don't have sun for 3-4 days because it's raining, what do? So we need a backup boiler. So combining gas boilers, condenser gas boilers with solar collectors might be a good idea. And okay, so we have to differentiate between the energy production and the heating distribution devices. So those are heating distribution devices. So we can, with these heating distribution devices, we can use gas boilers, pellets, or pellet boilers, or solar collectors, and then we can have radiators. We all know radiators. We all know what a radiant floor is, so we have pipes circulating hot water, and then we have tiles or flooring, whatever, but we have a warm floor. In my opinion, this is the most efficient way, because and when it comes to comfort, this is my favorite. Okay, radiators are good, they are cheaper, but in terms of comfort and energy efficiency, radiant floors or even radiant panels, we can have the same concept, but in walls instead of floors. And then something different is the fan coil unit. The fan coil unit, it's something that works with hot water, but then this hot water heats up air. Okay, so it's more complicated. We will explain what a fan coil is, but we can use these heating distribution devices with different energies or different boilers or different solar collectors. At the end, all these elements are connected to a buffer tank. Okay, so we always have the heating or the heat generator, which is the boiler or the solar collector. We have a buffer tank with water, and then we have to connect this buffer tank to those heating distribution devices. Something like this. Okay, so we have a boiler. We can have expansion tanks, and if the building is complicated, we have different circuits. As you can see, we have circulating water pumps because we have different circuits. The bigger the building or the more complicated the building, the more complicated this heating system is. So we can end up having mechanical rooms like this. So this is a mess. Again, we don't have to, as architects, we don't have to design mechanical rooms. So this is a task for mechanical engineers. But we need to know what it takes. So if we are designing that building with all these pipes and all these circulating pumps, we need to know, because the mechanical room has to be quite big to accommodate all these pipes, tanks. Okay, so we don't have to design mechanical rooms, but we have to dimension mechanical rooms. Usually those mechanical rooms are on the basement, and then we have to distribute this cold and hot water throughout the building. And order is very important. Here we have a color code. We have red for hot water, we have blue for cold water, we have green for what? I don't know. Probably because we have a fire extinction systems with sprinklers, so we need water for this as well. So probably this green is for the fire safety system. That I want to convey the idea that a building is something complicated. A single family house, it's a piece of cake. We all can design single family houses. But if we are working with office buildings or commercial buildings, we better work within a team with structural engineers, mechanical engineers, because buildings are getting more and more complicated, and well, it's difficult. But the first thing, this is not the first decision we have to make when we are starting the design process. So at the first stage of the design process, we have to work with the idea, what we want to do, the shape of the building, materials, something like that. So something that you will learn in design. But after that, before moving on in the design process, we have to stop and think about what kind of mechanical systems we are going to need on that building, because that will affect our design. So if we don't make that decision before the end of the design process, then we will have to change things. When we are designing the building, okay, I'm done with the design. Then the building or your design goes to another department of the firm, and probably the mechanical engineers are working there, and they say, you have to change everything because we have to work with the air handling units and piping systems and whatever, and you haven't designed any shafts or the false ceiling is too low. So we have to, after the first stage of the design process, we have to stop, we have to start thinking about mechanical systems, and once we are done with the mechanical systems, then we can continue the design process, because if we don't do it, if we don't do these kind of things, we will have to change a lot of our design, we will lose a lot of time, we will lose a lot of money, and there will be wailing and grinding of teeth. Okay, thank you very much.